next picture and introduce our next presenter, who also happened to take this picture. As you can see here, we've got a series of images from the lunar eclipse in January of 2019. And Tyler Westering, who is actually going to be presenting on the topic of thriller astronomy, will go ahead and we'll get into that in just a moment. But Tyler is the one who took this picture. So you can see the progression of the shadow or the penumbra of the moon, of the Earth's shadow coming across the moon. In the middle, the Earth has completely blocked most of the sunlight from the moon. And then again, as the eclipse passes and the shadow of the Earth moves off of the moon. So Tyler, great picture. And let me go ahead. I'll turn the floor over to you. But before I do, actually, what I'd like to ask is if you do have questions in the chat box, you can chat to everyone, but it might be best if you make sure Tyler's listed in the two. So you can go ahead, if you click the drop down arrow and you just type a T in up there at the top of the search bar, you'll see Tyler Westering. If you put him in the two, pretty sure all of your questions or comments will go directly to Tyler. So without any further delay, Tyler, the floor is all yours.
Awesome. Thank you, Mike. Like I said, like Mike said, I'm Tyler Westering. I'm also the VP of Observing here for the NSA Club. Let me just share my screen here. All right. Perfect. All right. So today I titled today's presentation as Thriller Astronomy because I wanted to highlight some of the really thrilling events of astronomy, because astronomy can be thrilling. And I'm just going to show you a couple of those type of events that occur today. So like I said, this is going to be your guide to the special events that occur in astronomy. So let's talk about what events make astronomy so thrilling. And the first being lunar eclipses, second being solar eclipses, the third being comets, and finally the fourth being meteor showers. So I'm just going to dive into these very quickly. And the first we'll go into is lunar eclipses. Lunar eclipses. So as you can see in this picture, that's a total lunar eclipse. There's actually three types of lunar eclipses, and that includes penumbral, partial, and total. And I'll get into what the difference of these three are in a little later. But first, let's really talk about the first of eclipses, which is called the penumbral. Now, penumbral eclipses I call are the most boring of eclipses. However, they're still interesting to watch. Think of the penumbra as actually the outer shadow of the Earth. So during an eclipse, and a lunar eclipse, what is happening is the shadow of the Earth is actually covering up the moon. So if you were viewing from the moon, you'd actually be seeing an eclipse of the sun. The Earth would actually go and pass in front of the sun. And that's what an eclipse is on the lunar side. So penumbral lunar eclipses occur when the moon only passes into the penumbra of the Earth's shadow, which, like I said, is in its outer shadow. If you ever look at a very point source of light, you can only see one shadow, but the sun is a little more elongated. So you can actually, if you look at it, you can see two shadows. And that's exactly what's happening with the Earth. Like I said, if you're looking from the moon's surface during a penumbral lunar eclipse, you'd actually be seeing the Earth only blocking part of the sun. And that's what a penumbral is. Now, the next exclusively penumbral eclipse, this is just a penumbral eclipse, will occur for North America, will occur March 24th through 25th, 2025. So quite some time until then. However, you can still see a penumbral eclipse in the upcoming partial and total phases, because both partial and total eclipses also have a penumbral phase also. So let's talk about the second type of eclipse, and that's a partial lunar eclipse. So here's some pictures from a partial lunar eclipse. It occurs when the moon passes through the Earth's umbra, or inner shadow. And if you were viewing, let's just say if you were viewing on the part that was covered, on the moon, if you were viewing this from the moon and you were seeing, you were in the shadow of the umbra, you'd be seeing a total solar eclipse, the Earth actually passing totally in front of the sun. And that's what it would be. However, partial lunar eclipses, not the whole moon gets to see that total solar eclipse. So that's there. All partial lunar eclipses also have a penumbral phase, as I said earlier. And you can see it here. It's very eerie to watch a partial lunar eclipse because it almost looks like alien type of phases of the moon, which I always enjoy to watch, and it's just kind of eerie to see. The next exclusively partial lunar eclipse for North America will be May 26, 2021. However, actually, if you're further west, it will be a total lunar eclipse. However, the moon will set before we get to see that, so you'll only be able to see a partial lunar eclipse. And in this case, though, the moon will set when it's about 57% covered by the Earth shadow, or the inner shadow. And so you'll be able to see that if you have an unobstructed view to the west in the pre-dawn hours of the morning. That's like 5 a.m. So if you're an early riser, or if you like to stay up really late, then this is for you. This is an option for you. Now, we will go into the next fully visible partial eclipse to Illinois. This is from penumbral phase, partial, and then penumbral, back to penumbral, will occur on November 19th of 2021. So this year. And this eclipse is going to be an almost total lunar eclipse. It's going to be about 97% immersed in the Earth's shadow. So it's going to be a very deep eclipse, and it'll almost look like a total lunar eclipse, just a little brighter. So then we'll go into total lunar eclipses and what those are. So when the moon is fully immersed within the umbra, Earth's inner shadow, that's what a total lunar eclipse is. All total lunar eclipses also have a penumbral and a partial phase too. So you get kind of 3 eclipses in one, so to speak. Basically, you can see this picture. These are both during a total lunar eclipse, during totality, it's called. You can see that it's not black like you'd expect. You'd think that the moon would be totally gone, it would just disappear from the sky. However, this is not the case. What happens is during this eclipse, actually sunlight gets to pass through some of the Earth's atmosphere. And if you think about it, basically, it's all of the Earth's sunrises and sunsets, all that light passing onto the moon's face, and that causes this red color. And what's also interesting about this is, depending on how polluted the atmosphere is, it actually depends on how bright and what color the eclipse is. So if you have like a volcanic eruption, so to speak, the moon can actually totally disappear and turn black. Or if, let's just say, the atmosphere is very clear, then you can actually have an orangish reddish eclipse. But normally it's about middle ground for most of the eclipses, because you normally have some forms of pollutants in the atmosphere, like a wildfire, etc., or something like that. So the next total lunar eclipse, fully visible from the Illinois area, will be May 15th through 16th of 2022. So next year, in about a year, there'll be a total lunar eclipse that you'll get to see from penumbral to partial to total to partial, penumbral, and then there you go. So you'll be able to definitely see all 3 phases and what they're exactly like. That leads me to my second thriller, and that's solar eclipses. Solar eclipses are very cool to watch. I'd say the partial phases of lunar eclipses are a little more interesting than the partial phases of a solar eclipse. However, the totality phase of a solar eclipse is so much cooler than of a totality of a lunar eclipse, and I'll get into why that is in a second. There is 3 types of solar eclipses, and the first being a partial, second being an annular, third being a total eclipse, and then there's actually theoretically a fourth one, and that's called a hybrid eclipse. And basically what that is combining both an annular eclipse and a total eclipse, just depending on your location, because of the distances. But before I say anything else, I can't stress this enough. Never under any circumstance look at the sun without any protective gear for the sun. This doesn't include sunglasses. You need solar filters. And these are actually pretty cheap. I even put eclipse glasses on here, which don't they look very fashionable? I mean, you look amazing in those. And they're kind of like a keepsake to keep you remembering from the eclipse. So make sure if you're looking at a partial solar eclipse of the sun or an annular solar eclipse to wear or have some form of protection from the sun. And that's definitely very important, as if you do look at the sun without any protection, you can theoretically go blind or partially blind too. So unless you want to be blind, which, yeah. So let's talk about partial solar eclipses first. This is when the moon partially blocks the sun from our point of view. Through a telescope, what's interesting is you can actually see the moon's mountains and valleys along the limb, which is like the outer extent of the moon. And the next partial solar eclipse is actually coming up in about a month or 2 months. And that's on June 10th, 2021. Now, this eclipse is interesting because it'll also be an annular solar eclipse, which I'll get into in a second, but it won't be here. We'll only be able to see the partial phases. And it'll also be a sunrise eclipse. Because the moon will be actually actually in progress during an eclipse on the horizon as the sun rises. So you'll definitely need an unobstructed view to the east right when the sun rises to see this one. So that goes into my second one. That's annular solar eclipses. And now these are very interesting looking eclipses. This is when the moon is too far away from us to actually totally block the sun. Now, what happens is this is the case, and you actually get this ring around the moon during this of sun, and so it looks very it looks like a ring of fire. That's how many people describe it. Now, during this this type of eclipse, even during annularity, which is when the moon is in the center of the sun, you do need a solar filter. Just making that clear. You do need that. And during annularity, it gets very dark out, but not as dark as during the total solar eclipse. So just think maybe just before sunset, it gets about that dark. The next annular eclipse visible in the US will be on October 14th, 2023. And I'll get into that a little later. Finally, we got the most grand eclipse of all, in my opinion, and many other people's opinions. And that is total solar eclipses. If you remember back in 2017, we had one in August. That one is amazing. I went to Missouri for that one, and it was just amazing. And like I said, this is one of the grandest, if not the grandest, astronomical events. And basically, it's a combination of what the sun looks like, what the moon looks like, and what the landscape around you looks like. Because during this time frame, when totality happens, it basically gets as dark as 90 minutes after sunset, and the sky looks like there is a sunset like 360 degrees around you, because if you're looking out in front of you or behind you, you're actually seeing where there is not a total solar eclipse. Now, the thing about total solar eclipses is the path for them is very narrow, sometimes like 70, 100, 120 miles in across. So it's a very narrow path. So you definitely got to make sure you're in the path of totality to see this. During this time, you actually get to see a bunch of things on the sun too. And that includes what's called the diamond ring effect, Bailey's bead, and the corona. The diamond ring effect is basically sunlight just shining through one of the valleys of the moon. And this normally occurs right when totality begins and right when it ends. So normally you get two, sometimes you don't, just by geometry and stuff. Also, Bailey beads are basically the just smaller diamond rings, and they occur like different. There's normally like 4 or 5 of them, and yeah. Now, what's interesting about total solar eclipses is you do not need a solar filter during totality. However, leading up to totality, you do need one, and afterwards. So during totality, you don't need a solar filter, and if you don't take off your solar filter, you're not going to see anything, and you'll be very sad when totality is over. Now, another thing about totality is it's super, super, super short. It's only depends on the time frame. It can range from 2 to up to 10 minutes. However, normally the average is about 4 to 5 minutes. So it's very short, and it does not feel like 4 to 5 minutes. I know from experience. So definitely keep that in mind. So an upcoming total solar eclipse will be the 2024 total solar eclipse, April 8th. And its max duration of totality will be around 4.5 minutes, located in central Mexico. However, if you live in Texas, or if you go to Texas or Arkansas, you can actually see about 4 minutes of totality there. And you can see this map. It shows you the path of the 2017 eclipse. You got the path of the annular solar eclipse that will occur on October 14th, 2023. And then you got the annular solar eclipse that's occurring in 2021, you can see in Canada. So as I said, it crossed paths with the 2017 one too. So that's also interesting. And that's what Tim actually highlighted on. So we're just going to talk really quickly about comets. Comets are another thrilling aspect of astronomy. They're basically dirty snowballs. Many people refer to them as they're condensed gas and dust and stuff, and rock that emit it and as a form of tail because of the solar radiation that's getting bombarded by them. And you can see in this diagram, there's the coma. You got the tail, and there's normally 2 tails, and that's the ion tail and the dust tail. So they actually separate. And comets are very unpredictable. Many people say that because what happens is a lot of the newly discovered comets are the ones that are bright because we don't know them. We don't know what they will do. And so what happens is when they're far away from the sun, they actually start to emit gas a lot sooner because they're new, so they have a lot of excess gas and dust, so they like to emit it before, and so they appear to be really bright. But what happens is when they get closer to like the Mars orbit or Jupiter orbit, they start to fizzle out because all this excess gas gets burned out really easily. And then basically sometimes they just totally dissipate. And that's the reason. And a lot of comets also are what's called sun grazers. They get close to the sun and they disintegrate. And many comets have disintegrate. I don't know if you remember Comet Ison back in 2013. I was so excited for that one. It was going to be brighter than the full moon was the advertisement. And well, it did not make it. It totally disintegrated because it was too close to the sun. However, when you do get a good comet, like Comet Neowise last year, it's spectacular. You see the tails and stuff. Amazing and beautiful. So, and then the last thriller event that occurs are meteor showers. This is one of my favorite events in astronomy, meteor showers. I love watching them because it's just they're unpredictable and they're just fun to watch. Meteor showers are just debris left from comets, actually, or asteroids. And there's 2 types of meteor showers. There's major and there's minor. Now, interestingly enough, there are actually 112 named meteor showers, and there's actually a couple more than that that just haven't been named and stuff. And 9 of those are considered major, 9 or 10, depending on who you ask. And one thing I just wanted to tell you is a lot of people go out to watch meteor showers and they're expecting, when they hear the meteor rate, which is how many meters per hour people say, they expect to see that many meters per hour. However, this is not the case. If you're, let's just say here in Chicago, you have light pollution, which is a big aspect. You got to go to a dark sky to see meteor showers in their full glory. Another thing is when these meteor shower rates are predicted, it means that the radiant, which is where these meteors originate or seem to originate in the sky from has to be above at the zenith, which is the highest point in the sky. Which doesn't occur for most meteor showers. So when you hear these rates, don't expect to see that much. Maybe expect to see half as much as those if you're at a dark sky even. However, sometimes that's not the case. Sometimes they can produce that many. And also, meteor rates aren't constant. Don't expect to see, when you hear 60 per hour, don't expect to see one every single minute. What happens is they come in spurts. So let's just say you get out there and you sit out there for 15 minutes and you're like, I haven't seen a whole meteor once. You might go inside, and then right after, 20 meteors in 1 minute could occur. That's just how they work. So definitely, if you're gonna watch a meteor shower, go ahead and spend at least an hour out there, if not more time, because you'll be surprised at how many you'll see. And here's the meteor shower chart. You got the quadranids, Lyrids, Aquariids, which the Aquariids are the ones that are going to peak very soon. Southern Delta Aquariids, Perseids, Leonids, Geminids, Orionids, and Ursiids. So meteors actually appear to radiate from a constellation, and that's what gives them their names. Now, the most interesting shower I'd say on this are the Leonids, because the Leonids actually every 33 years have an outburst, and they can produce over 1,000 meteors per hour. And some years they can produce over 100,000 meteors per hour. Just imagine that, like that'd be crazy. So this last occurred in 2002, so 2035 is when the next forecasted one is, and I think that might be on a full moon, of course, so gotta love it. That's just how astronomy works, people. So let's talk about the Aquariids really quick, and then I'm going to wrap up. They peak on May 4th through 5th, so coming up really soon, and they can produce up to 25 meters per hour in the northern hemisphere and about 60 in the southern hemisphere. And there's the radiant, the map for the radiant. You can see they're in Aquarius, and the best time they're seen is during the pre-dawn hours when the radiant is highest. And the reason that they're better in the southern hemisphere is because the radiant appears higher in the morning sky. So another cool thing about this shower is it originates from Comet Halley. So that's just a fun fact there. So that is all I have right now. So if you have any questions, go ahead and put it in the chat. Let me see. I think I got something. Okay.
Tyler, great
awesome.
job. Great presentation. Do you have a question to answer?
I don't think so.
Wonderful. Wonderful presentation. A lot of detail, a lot of great information that you shared. And again, great example to the audience of the diversity and just the age difference that's represented across our club, and of course the passion for the hobby. So without any further delay, Wally, let me turn it over to you, and you can go ahead and announce our next presentation.